Hello, welcome back. We are going to start a new example to study a different topic. What you see, the histogram you see on the slide is from 2010 census and it's state population data. So here, the largest state is California, which has 37 million population, a population of 37 between 37 and 38. And Texas has 25 something million, and New York has 19 something million, Florida has 18 something million, and other states are located here. So, by the way, I include TC, so there are 51 states in this data. And what you're going to do here is, suppose that this is our data. We have 51 observations on the populations. The populations are our observations, and if you calculate the mean, it is 605, 6.05. So on average, one state has 6.05 million. It's a typical number for a state. But look at the distribution. Mean is here. Mean is the at the beginning of the interval between 6 and 7. So mean should be somewhere here, 6.05. So then the problem is it the center? We are looking for a center. The mean has to be a center, but the problem is on the right side of the mean there are 17 states from the data. I'm going to post the Excel file together with the slide so that if you are curious, you can uh, see the data, or actually you can just type census state population data, then you can look at the data. It's available. It's easy to see. It's on Wikipedia. Anyhow, the point is now I have to think about if it's a center because there are twice more states below the mean than above the mean, right? 17 states are greater than mean, have more population than 6.05 million, but 34 states are smaller than that. So, it's not balanced. It's unbalanced. It's much heavier on this side. So, uh, we have to fix it. If you may not like it, it depends on the context, but it's a problem. It's a problem. It's not desirable. So we are going to define an alternative to that. Define a new measure, which is going to divide the sample in half and half. So I am going to find exactly the middle of the data, and if I cut the data at the middle, then it will be divided exactly into half and half of the sample. We are going to call that median. So its idea is simple. That's simple. Median is exactly simply the middle value. Where is the middle? Where is the middle value? And we are going to denote it as median of x or simply MED of x. Both stand for median. And in our example, we have, as I said, we have 51 states, including DC. So then, where is the middle? The middle of 51 numbers is the 26th largest number. So when you order the numbers from the smallest to the largest, so smallest to the largest, then there the middle will be the 26th number. In our data, it's Kentucky. So Kentucky is the exactly the middle state. So that means 25 states are smaller than Kentucky and the other 25 states are larger than Kentucky. So very interesting, simple. So Kentucky is the median. Of course, median is a number. So Kentucky's population is the median, which is 4.34 million. That's the definition. It's that simple. When you actually have 51 numbers, you can simply count what is the median. And we are going to study how to calculate this first. By the way, median is here. Median is here. It's on the interval between 4 and 5, and it's at the left, near the left side of this interval. And if you count these numbers, there are 25, and if you count this side, there are also 25. So median, when you cut the histogram at median, then on the left and on the right, it must be balanced. It's balanced between the left and right. And also, by the way, if you ask me, then what is the difference? What does it mean? What does the difference between the mean and the median imply? Nothing. Like at this moment, uh, uh, I would not say a lot. So I put it this way: even if you know the mean, you cannot tell where the median is. So there is no direct relationship between the median and the mean. So they are usually different. And let's see how to calculate the median first. How do we calculate the median? When also the method to calculate the median depends on how the data are presented. And remember, when we calculate the mean, there were two different ways. First, when you have a raw data set, and second, when you have a probability or frequency distribution table. And same here, the median also, the way to calculate the median also depends on the way the data are presented. So let's think about this. Suppose that you have raw data. Here we have 5 states. Simply, I could list 51 states here, but that's not efficient. So let's restrict our sample to Pacific states. So Alaska, California, Hawaii, Oregon, and Washington. By the way, I hope they're doing well in these days. I heard they are suffering a lot from the fire. Best wishes for them. Anyhow, coming back to this example, when you have these 5 numbers, Alaska has 0.71 million population, California has 37 million, blah blah blah. What is the median? When you want to calculate the median, the simplest way, if possible, is to rearrange the numbers in the ascending order or the descending order. It does not matter. So even if you flip that, anyhow, the middle one is the median. So smallest to the largest. Or if you go the other way, the median is always at the third place, 3.83. Because there are 5 observations. When you have 5 observations, obviously the third one is the middle. So automatically that's the median. When you order them, then find the middle one. So median is 3.83. And just for your reference, as I said, the mean is 9.98. You don't know you cannot tell, you cannot calculate the mean from this number. To calculate the mean, you have to add all these numbers and divide by 5. So that's, if you do that, you get 9.98. They are different. It's natural. They are different. And the difference is much larger in this example than the 51 states. And another tricky case is when you have even number of observations. I now consider New England states, and there are 6 states: Vermont, Rhode Island, New Hampshire, Maine, Connecticut, Massachusetts. And I already ordered them from the smallest to the largest. So the problem is there are six states, so middle is here. You have to cut the sample at this point. Then what is number here? And in this case, simply take the average of these two guys. Take the middle of these two middle values, right? There are two middle values. There is no single middle value, but two, because the sample size is even. And then take the middle of the two, which is 1.325. The median is 1.325 million, and meanwhile the mean is 2.41. So I calculated the average separately, and it is 2.41. There is no pattern. The mean, overall, the mean was greater than the median, but uh, I will explain why later. So it's easy when you have raw data. You have to find the middle, order them and find the middle one. Of course, when you have larger data, it's impossible by hand. Then you have to use Excel or like a program, and then it's an easy task to a computer. So don't worry about that. Just understand the principle. Okay, I will stop here, and in the next video, I will show you how to calculate the median in a different setup when you have a probability distribution table. Thank you. See you in the next video.